So for this entire section of the course, we're going to be talking about congruent figures and corresponding parts. And after we talk about congruent figures generally, we're going to drill down specifically to congruent triangles, but this video is just an introduction to what congruent figures are. We've already seen a little bit of congruence when we were talking about congruent segments and congruent angles. Congruent segments have equal length, congruent angles have equal measure, just generally congruent objects have equal size. That same type of idea can be extended to the realm of congruent figures, where we can think of congruent figures as just copies of one another. So if we were to take that triangle over on the left and copy it, just a copy still in that orientation is a congruent figure because all of the sides are the same length and all of the angles are the same size. This would still be a congruent figure if we were to change its orientation. So now the right angle is in the bottom right corner rather than the bottom left corner. Because the sides are the same length and the angles are the same size, these are still considered congruent figures, even though they are oriented slightly differently on the page. Similarly, let me move that over here. Similarly, we could do the same thing for the quadrilateral over on the left and just drag it down a little bit, and now we have two congruent quadrilaterals. Even though they overlap a little bit, the quadrilaterals themselves have sides that are the same length, regardless of whether or not the figures overlap. And so that is really what the critical part of the definition of congruent figures is. It's that congruent figures are identical in every way. Their corresponding angles have the same measure, and their corresponding sides are the same length. Go ahead, pause the video, copy down this representation of congruent figures, come back when you're ready to see a few more important things about them. So continuing along with the example from the triangles, we could see that two congruent triangles will have three angles that are the same length and three angles that are the same size and three sides that are the same length. So in these two triangles, ABC and DEF, you can see that the pieces of ABC are all marked as congruent to the pieces of DEF. And so for one example, angle ABC is congruent to angle DEF. Every part of one congruent figure is going to have its corresponding part in another congruent figure. And so corresponding parts in congruent figures represent the same angle or the same side in both figures relative to the construction of the figure. They are specifically congruent segments or congruent angles. So we either have corresponding segments or corresponding angles, and in congruent figures, corresponding pieces are the same size, so they are congruent. So go ahead, pause the video, copy down this definition for corresponding parts, and come back when you're ready to move on. So one of the ways that we can tell corresponding parts is in the names of the congruent figures. And what's particularly important about the names of the congruent figures is that in the case of these two triangles, we can name the triangle on the left whatever it is that we want. So let's call this triangle CAB. Doesn't matter, we just have to move around the congruent figure so that in a triangle, it's easy. Start at angle C, then go to A, and then go to B. If we had a quadrilateral or a pentagon or a hexagon or something like that, and we were naming the figure however we were going to name it, we just choose one vertex to start at and then walk around the figure. Once we've named one of the figures, we have to make sure that the other figure that's corresponding to it is named in the exact same way. So if we name this triangle CAB, then C is this angle down here that's marked with two blue arcs, which means when we name the congruent triangle, we have to start with the same vertex in our other triangle. So this then becomes triangle F, and then in CAB, we go along the three dashed side to the green angle, DE. These two triangles are congruent. You will also notice that in the last few screens, we've had angle ABC and angle DEF congruent, but they also walk around the figures in the same orientation. And by walk around, I mean start at the same vertex and then follow congruent parts around the figure until we get to the last vertex. So we can actually extend that to triangle ABC is congruent to triangle DEF. But if we said triangle ABC is congruent to triangle FDE, those are not congruent because triangle ABC starts with the green single arced angle and then goes first to the right angle before going to the other acute angle, and angle FDE does not. They may be congruent triangles when named one way, but if the order of the points is wrong, their naming is not correct, and they are not congruent figures. Naming is important. Once we have those names, then the names of congruent figures will always tell you the corresponding parts. So whatever vertex is named first in one set of congruent figures, it is corresponding to the first vertex that is named in the other one. So angle A and angle D, angle B and angle E, and angle C and angle F. Those are the corresponding angles. And now to find the corresponding sides, we just look at the same sides between the two angles. So one set of corresponding sides goes from angle A to B because those are the vertices that were named first, and another goes from D to E. So AB and DE are corresponding sides. BC and EF are corresponding sides. And AC and DF are corresponding sides as well, because their vertices occupy the same place in the names of these congruent figures. So what we're going to do is we're going to see a bunch more examples of congruent figures, one that we will walk through again together, and then 3 more that you will name and then identify the corresponding parts for. So the first 2 figures that are congruent are pentagon ABCDE and VWXYZ. That means that the corresponding angles are A and V, B and W, because pentagon VWXYZ is actually flipped vertically from ABCDE, C and X, D and Y, and then finally E and Z, all because they occupy the same place in the naming of those congruent figures. Then we have a whole bunch of sides that are corresponding to each other. So between A and B, that corresponds to the side between V and W. BC corresponds to WX, CD corresponds to XY, DE corresponds to YZ, and EA corresponds to ZV. So again, we can take the naming and say AB and VW, those are the first 2 vertices, BC and WX, CD and XY, DE and YZ, and then EA and ZV, or we can just name the congruent angles and walk along and around the figures in the same orientation. So for these first set of figures here, we know that these 2 triangles are congruent and they have their corresponding parts marked as congruent. So go ahead, pause the video, name these 2 congruent figures, and then name their corresponding parts. So there are lots of correct ways to name these figures. In the one at the top, I'm going to start with G, because it has a single arc. You can start wherever you want, and say GFH. 1 arc, 2 arcs, 3 arcs. That means we do the same thing in the triangle at the bottom, which is triangle TSU. This may not be the same name that you came up with for your congruent figures, but as long as they follow the same order around the shape, then your naming is correct. Check with the arcs, check that your vertices match up in a way that all of the sides with the same amount of dashes line up. And so then what that means in terms of corresponding pieces is that F corresponds to S, G corresponds to T, and H corresponds to U. And that means that our corresponding sides are GF and TS, FH and SU, and HG and UT. So all of those segments are corresponding so that they are all congruent. Moving on to the next one, 2 pentagons here. Go ahead, name the congruent figures. If things seem to be congruent, they are congruent, even if they seem a little bit off because it was constructed here. Assume that the things that look like they should be congruent to create congruent figures are. Come back when you're ready to see the answers and move on. So if we start by naming the pentagon on the left ABCDE, then we know we have to follow this sort of path along the outside from what looks like a right angle up towards the convex angle, or the concave angle at D, and then back to E. So the corresponding and congruent pentagon is F, G, H, D, E. That means that A corresponds to F, B corresponds to G, C corresponds to H, D corresponds to itself, and E corresponds to itself, which is totally fine. We can do that. So then, as far as the segments are concerned, AB then, the length of AB is the same as the length of FG. BC has the same length as GH. CD has the same length as HD. DE has the same length as, well, its corresponding pieces are just DE. And EA corresponds to EF. One last example, if you're feeling really confident with naming your congruent figures, you can actually stop the video here and then move on to the extra practice there. If you want one more example, here it is. Go ahead, pause the video, name the figures, name the corresponding parts, come back when you're ready to wrap up the video. So let's start in the middle here with naming this IHGF, going to the convex angle up to the point there and around to F, which means the same thing happens in the figure at the right in the same order. So it is IHKJ. Then our corresponding angles are F corresponds to J, G corresponds to K, GHI, this is this angle, corresponds to KHI in that angle, and then angle HIF corresponds to angle HIJ as you walk around the corresponding quadrilaterals. Notice that we can say corresponding vertices, but as soon as we talk about corresponding angles, we probably need to give the full three vertex name of them so we know exactly which angle at these intersection points we're talking about. Then, as far as the corresponding parts are concerned, IH corresponds to itself. Doesn't always have to, but in this case it does. HG corresponds to HK, GF corresponds to KJ, and FI corresponds to JI. So congruent figures have congruent sides and congruent angles. They can be named in a way that corresponding pieces follow from the naming of those congruent figures. So if we know, let's go back to a slightly easier example here. If we know that angles A and V are corresponding and B and W are corresponding, then as soon as we name the congruent figure, the first pentagon A, B, C, D, E, we have to continue in that same relative order around the other figure, starting with the vertices that correspond to A and B, V, W, X, Y, Z. In those names, they will tell you the corresponding parts which are congruent and the corresponding sides and the corresponding angles.